In this lesson, we're going to be graphing from vertex form. By the end, you should be able to graph equations from vertex form and identify certain features. Vertex form, the difference between vertex form and standard form. Remember that standard form is ax squared plus bx plus c. And vertex form is a parentheses x minus h squared plus k. Now, we call it vertex form because in vertex form we are given the vertex. And we're given a couple other bits of information as well, such as the size of the parabola. So in vertex form, A is going to tell you if our parabola is going to be narrow or if it's going to be wide. And then it's also going to tell you if it's going to be up or down, just like it would in standard form. In the H is going to tell us two things. It's going to tell us the axis of symmetry, and it's also going to tell us the x-coordinate for our vertex, and K is going to tell us the y-coordinate for our vertex. Now, it's very important to recognize here that the H does not include the negative sign when we're talking about its value. So we're looking only at the number, right? So if we had y equals 2 times x minus 5 squared minus 7, h would be positive 5. But if it was changed to a plus, then that indicates that a negative value was put in there. That would be the only thing that would change that. That would be negative 5. Now, we've seen this before. If you recall, when we did point-slope form, it was that same thing. So we need to watch out for that when we're looking at vertex form. That it's minus, and so if it changed, then that means that a negative value put in. So you're having to look at it kind of backwards. Minus 5 means that it's a positive 5. A plus 5 means that h is negative. Now, we're going to talk about the domain and range. So from the equation, you should be able to list or state the domain and range without having to graph. Now, our domain or range, remember, could be written as an inequality or interval notation. We looked at that in the last video. The domain is going to be all real numbers always, unless we're looking at a real-world problem. So negative infinity to infinity, and again, as an inequality, it'd be negative infinity is less than x is less than infinity. In an interval notation, it would be parentheses negative infinity to infinity, close parentheses. The range, okay, if the curve opens upward, then it's going to be y is greater than or equal to the value of k. And if the curve opens downwards, it's going to be y is less than or equal to the value of k. Just determines, is k going to be the largest value that we can have or the smallest value that we can have. Again, you can write it as an inequality, or you can write it as interval notation. When we're graphing from vertex form, we're going to identify the vertex. You're going to pull h and k. Remember that when we're pulling h, don't include the negative, and that if it changed to plus, that means that a negative value was in there. Make a table, just like we did before. Find 2 points on either side of the vertex, put them back into the equation to get out their y values, and then graph. And the sketch does not necessarily have to be exact, but we want to get it as close to exact as possible. When we're finding the size of the parabola, so if we're having to, again, check how wide it's going to be, okay? Identify the vertex, choose another point on the graph, and then substitute those values in for h, k, and x, and y, and solve for a. A, remember, determines the size. So if we know everything else, we can plug it into the equation, we can substitute them back into the equation, and we can solve for a. Let's look at the following equation. So we have the vertex form, negative 4, x plus 3 squared minus 7. Now, remember that h is going to tell us the axis of symmetry. And it should have been minus h, and so because we see a plus h, that lets me know that h is actually negative 3. So I know that h is negative 3. I know that k is negative 7 because it should have been plus 7. I know that a is positive 4. Those are my three values, or negative 4. Those are my three values that we have. So my vertex is hk, so if h is negative 3 and k is negative 7, my vertex is negative 3, 7. The direction of opening is going to be down. So it's going to be down because a is negative. And so my domain, remember, is always all real numbers. Or negative infinity to infinity. My range is going to be based off of k, so negative 7. And because this is a maximum, negative 7 is going to be my largest value. So I'm going to have y is less than or equal to negative 7. We're going to rewrite this function from vertex to standard form. And then we're going to use both forms and figure out or evaluate them for negative 1. So if I'm changing from vertex to standard form, I'm just going to evaluate this function. We do order of operations, so I have to take care of the parentheses here. Now be careful, because this is not x squared minus 1 squared. This is really x minus 1 times x minus 1 minus 3. So we're going to have to FOIL here. So when I FOIL x squared minus 1, that gives me x squared minus x plus 1. So that really is x squared minus 2x plus 1. Bring down to 3. And then we are distributing. So it's going to give me 3x squared minus 6x plus 1 minus 3. And then subtract the 3. That gives me 3x squared minus 6x minus 2. So my standard form is y f of x equals 3x squared minus 6x minus 2. Now we're going to evaluate 1 and negative 1 into both. Again, we should get the same thing in both. So if I use 1 in here, that would be 1 minus 1, which would be 0. And then 0 squared, which is 0, times 3, which is 0. So again, 3, 1 minus 1 squared minus 3. 3 times 0 squared minus 3. This would be 3 times 0, which is 0, minus 3, which gives me negative 3. If I substitute it into the other equation, I should get the same exact thing. So 3 times 1 squared minus 6 times 1 minus 2. 1 squared is 1. 1 times 3 is 3. Minus 6 minus 2. And then, okay, quick fix here. It should be positive 3 because I did not distribute the 3 here. So when I plug this in, this is actually going to be, this is actually not going to be here. So that goes away. So the positive 3 and the negative 3 cancel each other out. That gives me 0, so I have 3x squared minus 6x. Okay, now going back to this part. I don't have a minus 2 here anymore. That gives me 3 minus 6, which is negative 3. So now they match up. So again, this will be a good check for you. Again, if you don't get the same value, then you know that something was off in your other standard form equation. Again, if I plug in negative 1, I should end up with the same results. I won't have necessarily positive 3 or negative 3, but I should end up with the same value in both equations. Alright, we're going to sketch the graph of the function. If I want to sketch the graph, remember that I'm going to look for the vertex. The vertex in this case, remember, is found by using h and k. So I'm going to look for h. H is going to be equal to, well, because it's plus 4, I know that that's really h is negative 4. And k, because it says minus 6, and it really should be plus k, is negative 6. So now my vertex is going to be at negative 4, negative 6. So I could graph that point if I wanted to real quick. That way I have that point. I'm going to make a table of values, just like we did before. The vertex goes in the middle. We got negative 3 and negative 2 that come before. We got negative 5 and negative 6 that come after. It really doesn't matter which one I decide to put in here. I could put any number of values here. Now I do know that my graph has to open down because of this negative here. A is -1. So it does have to open down. So I'm going to pick the first two here. And I'm going to have -2 plus 4 squared minus 6. Well, -2 plus 4, that's 2. Minus 6. 2 squared is 4. So it's going to be -4 minus 6. That's -10. So for -2, I have -10, which means that for -6, I'll also have -10. And then for -3, that's -3 plus 4 squared minus 6. That would be negative of -1 squared minus 6. -1 squared is 1. So that's going to be -1. And -1 minus 6 is -7. So I've got -7 here, -7 here. So when I graph, I have 4, -6. And then I've got -3, -7, -5, -7. Nope. Yeah, that's right. And then I've got -6, 10. And I've got -2, 10. -2, -10. And then I graph my parabola. Again, it should have opened down, and it did. So I know that I have a good check here. All right. We're going to find the size of a parabola. So here we have our vertex, okay, which is 4, 0 on A, and we know that it passes to the point -110. So I'm going to plug everything else that I know in, and we're going to solve for A. So I have y equals, we don't know what A is, x minus h squared plus k. My y value in my point is 10. My x value in my point is -1. My vertex is 4, so h is 4. K is 0. And then I'm going to solve it for A. So I have 10 equals A times -5 squared plus 0. I don't need to write the plus 0. A times 25 equals 10. Divide both sides by 25, so that A is by itself. You get 10 over 25, or 2/5 is equal to A. So I know that the size of my parabola is 2/5. A is 2/5. Now, B is the same thing. I'm given multiple points on B, but I still need the vertex. I still need those points. So if I'm looking at B, and I'm looking at y equals a x minus h squared plus k. My vertex is here, which is -2, or no, not -2, -3, and +4. Okay. I have another point on here. I'm just going to use the point -1, 0. So my y value in this case is 0. A, we don't know. The x point is -1. My h is -3, so when I put that in, it's going to change that to +3 squared plus k, which is 4. Alright, so I've got 0 equals A, -1 plus 3, which is +2 squared plus 4. I've got A times 4 plus 4 equals to 0. Subtract 4 on both sides. That's -4 is equal to A times 4. And I know that the only thing that multiplies to give me to 4 that gives me -4 is -1. So no, A has to be -1. So the size of my parabola here is -1, which means that it's going to open down and that it's going to have a size of 1. This is how we graph, identify some of the features given the vertex equation, how we change from vertex to standard form, and how we find the size of the parabola when we're given the vertex and another point.